Okay, for what we have in section 1.4, question number 1, it says to find the slope of the line passing through the points 2, 5, and 8, negative 4. Keeping in mind that all ordered pairs are of the form xy, we will designate 2, 5 as the first set of coordinates, respectively, where we have 2 at x01, 5 for y01, and with 8, negative 4, we will say that that is going to be the second set of x and y values. Now, for what we have in the case of the slope, again, we have the slope formula, where we have the rate of change of y with respect to that of x, and with y02 minus y01, again, we have with y02, we have at negative 4, and we have minus y01, so we have minus 5. For x02 minus x01, okay, we have 8 minus 2. So we have for the change in y, okay, we have negative 4 minus 5, so we have negative 9. And we have 8 minus 2 is going to be at 6. And so we have for the slope in this ratio, we have a negative value, and this will end up at minus 3/2. For what we have in the case problem number 2, it says to find the slope and y-intercept of the line. Okay, and the line we have represented by the equation 5x minus 2y is equal to negative 8, and the object is going to be the equation in the form of y is equal to mx plus b. Now, starting off with what we have for 5x minus 2y equal to negative 8, we're going to first of all isolate the y term, and in the process, so we can move the 5x over, and with negative 2y by itself on the left, and getting this as close to the slope-intercept equation form as much as possible. We have negative 2y is equal to negative 5x plus 8. And we have with division by 2, in order to get the y by itself officially, we can divide all the terms out by negative 2. So we have here, we have y is equal to negative 5/2 of x. And we have 8 over negative 2 becomes negative 4. And we have, in this setup, okay, we have the slope-intercept form. So for the coefficient of the x term, that is going to be the slope. So you have the slope is going to be at negative 5/2. As for the negative 4 that follows, we have for the y-intercept. Now, Alex might want you to express this as y equals negative 4. If you were to put this in coordinate fashion, we would have the ordered pair 0, negative 4. So these are two different ways of saying the same thing that we have for the y-intercept. In the case of what we have for question number 3, okay, we have the equation of the line is given below, and we have 6x plus 2y is equal to 4, and it says to find the slope and the y-intercept. So a little bit of history repeating itself, at least from a procedural standpoint. So we have 6x plus 2y is equal to 4, and getting the y term by itself, I can take out 6x from the left-hand side, and we have 2y is equal to negative 6x plus 4, and with division by 2, okay, so we have negative 6 over 2 plus 4 over 2, and we have that y is equal to negative 3x plus 2. So we're going to have for the slope m is going to be equal to negative 3. And as for the y-intercept, okay, we're going to have on the y-axis at y is equal to 2. And in coordinate fashion, we're going to have at 0, 2. All right. So we have for the slope is going to be at negative 3. And for the y-intercept, okay, we have at 0, -2. Now, in terms of slope, along the lines of graphing, you're going to have a procedure where, again, you have change in y with respect to change in x. And if I were to read the order of the graph, or the motion of the graph in order from left to right, I would have moving down 3 units for every shift to the right 1 unit. And we can say that we have for the y-intercept, okay, so we have not at 0, -2, but 0, +2, okay. And so just making that correction. Okay, so we have for the y-intercept, okay, so we have at 0, 2. And if I go through a process of connecting points, okay, so if I have a process, say we have going from 0, 2, and say we have going down 3 units and shifting over 1 unit, and repeat the procedure, and we'll just throw in, say, 3 more ordered pairs, okay, and we have in the process, so we have 1, -1, also have 2, -4, and also in the mix we're going to have 3, -7. Okay. And in terms of the line itself, okay, so if I connect what I have here, I'll just throw in some others. Okay, so these 4 points are among infinitely many others. If I were to include any other points that I have, say, for -10, and for any points prior to the y-intercept, okay, just sort of working backwards, shift over left 1, go up 3. So I would have -1, 5, as well as -2, 8. And if I were to go beyond, say you have -3, 11. Okay, so you have a straight line that would be going downward. All right. Now, for what I have in the case of question number 4, so we have looking at the average rate of change of this function as x goes from 2 to 4. Now, for what we have in the case of h of x, now again, h of x, that is another way of saying what we have for y. So have, in this case, you have y is equal to h of x is equal to -3x squared plus 10. Now, at x is equal to 2, now you're going to have y is going to be equal to h of 2. So we're going to have, in this case, all right, so we have -3 times the square of 2, followed by the addition of 10. 2 squared is 4. -3 times 4 is going to be at -12. And adding 10. Okay, so we'll end up with -2. Now for what we have at x is equal to 4. So we will have y is equal to h of 4. So we have -3 times the square of 4, followed by the addition of 10. So we have -3. 4 squared is 16. -3 times 16 is going to be -48. Add 10, so we end up at -38. Now, for the average rate of change, okay, that's just another way of saying slope. And now for the slope designation, we would have, like, if you notice that the subscript to SEC, that's in reference to secant line, but you still have conceptually, okay, like your y2 minus y1 all over x of 2 minus x of 1. Now representing your y of 2, you're going to have what is h of 4, and your initial y value we have at h of 2, and then for x of 2 minus x of 1, so I have, again, you have for minus 2. That's the change in x. So if we fill in, okay, so you have h of 4, we have at negative 38, minus h of 2. H of 2 we have at negative 2. 4 minus 2 becomes 2. And for negative 38, and what's going to be plus 2, we have negative 36 over 2. And so we have for this outcome, it turns out that between these 2 points along the graph of y or h of x is equal to negative 3x squared plus 10. Okay, the average rate of change is going to translate to a negative slope value, which we have at minus 18. Now, for what we have with regard to the fifth question, okay, it says here that the graph of a function f is shown below. And it says to use the graph of the function to find its average rate of change from x equals negative 3 to x is equal to 1. Okay, and so for what we have for x is equal to negative 3, okay, so we have this particular point, so we have at negative 3, 1. And for x is equal to 1, looks like we were at 1, negative 7. Okay, and if I were to say connect the dots, so for the average rate of change, and I'll throw this in, you could use the slope formula. We'll just say we have over here okay. All right, so for what we have in the case of the change in the y values, they have 1, 2, 3, 4, 5, 6, 7, 8. So I have a drop of 8 units. And for the shift, I have 1, 2, 3, 4 units. And if you notice, okay, we have negative 7 minus 1 is negative 8. That's the change in y. For the change in x, I have 1 minus negative 3, so I have a positive 4 change. Now, so we have for the average rate of change, in this regard, okay, so we have, again, you could say we have, on the basis of counting the squares, okay, so you have change in y with respect to change in x, so we have negative 8/4, so that's going to go to negative 2, and also from the ordered pair approach, and for the change in y, have negative 7 minus 1, change in x, we have 1 minus negative 3, negative 7 minus 1 is negative 8, 1 minus negative 3 is 4, and negative 8/4 comes out to negative 2. So you could either use the squares or use the conventional slope formula. Still coming out to the average rate of change at minus 2.